download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about resistance. Now, resistance is a measure of how hard it is for the current to pass through a component. So the higher the resistance of a component, the harder it is for the current to pass through that component. Now, if I draw here some metal atoms, okay, and I'm going to draw some electrons that are flowing through it. So these tinier ones, these are the electrons flowing through. Okay, so this is conducting some electricity, and this is a charge flowing through. Resistance is caused when these electrons collide with the metal atoms or the metal ions in the metal. Okay, so resistance is caused when these electrons, i.e. electrons is what is the flow of electricity, it's electrons, when they collide with the metal atoms and metal ions in whatever it's flowing through, it causes resistance. Okay, so there are two important rules to understand: that the thinner the wire, the greater the resistance. Because if I draw here now an even thinner wire, so thinner with these metal atoms, you can see here that these electrons are going to bump into these atoms much easier because there's not as much space between them. It's a thinner wire and therefore it's going to be greater resistance. Okay, and there's a second rule as well, that the hotter the wire, so the hotter the wire, the greater the resistance. Okay, so the hotter the wire, the greater the resistance. Now that is because if the wire is hotter, then these atoms, these metal atoms, are vibrating much faster. Remember, when things are hotter, they move around faster. And if they're vibrating faster, there is more chance of the electrons to collide into them. So it's going to cause the resistance to increase. Okay, now resistance is measured in something called ohms, and that is the symbol for ohms there. Okay, so resistance is a measure of how hard it is for the current to pass through a component in a circuit. The few rules are: the thinner the wire, the greater the resistance, and the hotter the wire, the greater the resistance. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. Now this can all be linked with the following equation: V equals I times R, okay, where V is our potential difference, and that's measured in volts. Okay, now you'll remember from a previous video that potential difference is the driving force of a current. So it's what actually pushes the current, and it's measured in volts. So V equals potential difference, which is the driving force that pushes that charge around. Okay, I stands for the current, and that's of course measured in amps, and R is resistance, and as I said, that's measured in ohms. Okay, so that means that potential difference is equal to current times resistance. So let's go through a worked example. So an electric kettle uses a mains voltage of 230 volts and the current is 10 amps. What is the resistance? Okay, so first of all, we've got our equation here. So V equals I times R, and we want to work out our resistance. So we need to rearrange this equation to get R on its own. So if current is times over this side, it's going to move over here to be a divide. So V equals V over I equals R. Okay, so volt, potential difference divided by current is equal to resistance. Now we can write down what values we know. So our potential difference is 230 volts, and our current is equal to 10 amps. Again, now we can put this into our equation of resistance is equal to voltage, which is 230, divided by our current, which is 10, and therefore resistance is equal to 23, don't forget the units, ohms. Now I'd like you to have a go at these questions using that equation, and then we'll go through the answers after, so pause the video now. Okay then, let's go through these answers. Okay, so question 1, a light bulb with a resistance 60 ohms is connected to a 12 volt battery. What is the current? Well, you should have done 12 divided by 60, so you should have got 0.2 amps. For question 2, a hairdryer uses main voltage 230 volts. It takes a current of 5 amps. Work out the resistance. So you should have done the voltage, which is 230, divided by the current, which is 5, to get 46 ohms. Question 3, a toy tractor has a 4.5 volt battery operated motor. The resistance of the motor is 15 ohms. What is the current? So you should have done the voltage, which is 4.5, divided by your resistance, which is 15, to give you 0.3 amps. And finally, a portable CD player takes a 6 volt battery. The loudspeaker has a resistance of 4 ohms. What is the maximum current through the loudspeaker? So you should have done your voltage, which is 6, divided by your resistance, which is 4, to get 1.5 amps. And there is your answer. So we've now looked at what we mean by resistance and how we link resistance with current and potential difference using the equation V equals I times R. You can now test yourself using the quiz and on the exam questions on this topic, and if there's anything you didn't understand, please get into contact with one of our tutors who will happily help.